Okay, so in this video we're going to talk about how we can use the periodic table to figure out things about the electronic configuration of elements. The periodic table's a proper cool thing. You can get loads of stuff from it. Maybe not cool in the sense that you want to take it out clubbing on a Friday night, but cool in the sense that it will really help you in your exams if you know how to use it properly. So it's a big skill in chemistry being able to use the periodic table. So let's remind ourselves that on the periodic table, periods go across. So hydrogen and helium are in period 1, lithium, beryllium, boron, carbon are in period 2, etc. And then groups go down. So hydrogen, lithium, sodium are in group 1, beryllium, magnesium, calcium are in group 2. And if we remind ourselves from the previous video you'll have watched earlier, we know we have our 1s box, which is an orbital that can hold 2 electrons, our 2s, which also contains 1 orbital, our 2p, which also contains 3 orbitals. And then we'll just stop at 3s. Obviously they do go higher, but for this video we'll just stop there. Now what we can do is look at 3 things on the periodic table, and that will tell us where the final electron in any element is. And then all we need to do is fill up to there in our boxes. Let's have a look. So let's say I want to know where the final electron, the outermost electron in beryllium is, really quickly. All I would do is, first of all, I would look at the period, and that will tell me the shell that the final electron is in. So beryllium is in period 2. That tells me that beryllium's outermost electron, its highest energy electron, is in shell 2. So I know it's going to be somewhere here. If we look at the block that beryllium is in, now just to remind ourselves, these first 2 groups are the S block. This middle bit here in the divot is the D block. These 6 groups here are the P block, and at the bottom these 2 here are the F block. And we can see beryllium is in the S block. That tells me its highest energy electron, its outermost electron, is in an S subshell. So the second thing to look at is the block, and that will tell you the subshell. And then finally, I won't have enough space to write this down here, but I'll just say it. What we do is we count how many elements across in that block your element is. So beryllium is the second element across in the S block. So that means its final electron is the second electron in 2s. And then we just fill up to there, like so. So I'm going to give you a few questions, a few example elements, and all I'd like you to do is write down, using these 3 rules, where you think the outermost electron is. So I'll just say count across in block, and that equals the number of electrons in that subshell. Okay. So have a crack at carbon. Carbon you can probably do quite easily because it's only got 6, but do practice using these rules, because what if I said antimony, right? You're not going to be able to do that very quickly. So practice using these rules to figure out where the outermost electron, the highest energy electron, is in carbon. Welcome back. So carbon is in period 2, so its outermost electron is in shell 2. Carbon is in the P block, so its outermost electron is in a P subshell, and carbon in the P block is the second element across, so carbon's outermost electron is the second electron in 2p. Let's try another one. How about sulfur? Pause the video. Welcome back. So sulfur is in period 3. So sulfur's outermost electron is in shell 3. Sulfur is in the p block, so sulfur's outermost electron will be in a p subshell. And sulfur is 1, 2, 3, 4 across in the p block. Therefore, sulfur has 4 electrons in 3p. Let's try one more. Okay, how about oxygen? Pause the video. Welcome back. Okay, so oxygen is in period 2, so its outermost electron, its highest energy electron, is in shell 2. It is in the p block, so its outermost electron is in a p subshell, and it is 1, 2, 3, 4 across, so oxygen has 4 electrons in the 2p subshell. So I could actually write that on here. It would be 1, 2, 3, 4. Remember, they only pair up when they have to because electrons are negative and so they repel each other. So that's what oxygen would look like.